Okay, well, for people on the live stream, this is another episode in our insider's view of software development and software design. And the topic today is mathematical constants. So let's get going here. So we have a function called MathematicalConstantData, and let me pull up a documentation page that's been created for it. Where is this? This is in CVS. This is not in.
It's in the normal documentation.
Okay, fine. Okay, and then I will find out what this is. I think this is the first time I'm getting to see this. Oh, this is still not working. 11.3 prototype build, still not working with DocuTools. Can we please get that fixed? Okay.
It's basically the equivalent to mathematical function data, but as the name says, for constants.
Okay, so let's start off with. Okay, so let's take a look at some. Recommend some. Well, here let's take a look at the entities that are here. Oh wow, all kinds of wild things. What's a constant that is slightly obscure? Okay, Madelung 60 square lattice constant. Don't we have a way to compute that using like Epstein zeta functions or something?
Some of them can be, yeah, some of them have closed forms, yes.
Okay, so let's take a look at that guy there, for example. So if it does have a closed form, is there a, why is this taking forever? If it does have a closed form, is there a property that gives the closed form?
Yes. If you make all the association, you probably see everything.
Yeah, generally defining formula would be what you want.
Really?
Yeah.
That doesn't seem right. Defining formula? So, I mean, but some of these are sort of derived mathematical constants. So, okay. All right, so property. So let's see, we have a data set property here. Do we have a data set property?
No, actually, that's something I don't think I set up. Property association will work, though.
Okay, but this should work.
Yes, it should.
And why is it taking forever if it isn't going to work?
That I can't tell you. It hasn't been taking forever when I have run it on my machine.
You also tried a couple of things.
Oh, well, it does work.
I think it basically happens automatically. There's nothing to be done.
Oh, I see. Okay. Numerical approximation, how could it not have a numerical approximation? Oh, it does, but it isn't displayed here? What's the story? Let's try property association.
Exactly.
Why doesn't that autocomplete? It's not set in the autocompleter yet.
Oh.
Okay, that is a very unimpressive constant.
Okay.
How can that not be? How can it not even have a numerical value?
Yeah.
I don't know. I'm writing it down.
I tried a few this morning. They all worked fine.
No, well, it's okay. It's just my skill.
Well, try something obvious and make sure it works.
Yeah, okay.
Yeah, try. Let's see.
That's probably named after my acquaintance Peter Sarnak. Let's see whether his constant works.
I think it's the sum of primes.
Sounds like his kind of thing. Okay, that looks more encouraging. Okay, so we just in bad shape on this Madelung constant.
Yeah, obviously there shouldn't be anywhere we don't have a digit.
Right. I'm writing.
What is this weird thing? Extension backtick Sarnak constant.
Yes. Okay, so this you had suggested that we introduce this context pure math, which we are still working on, and it will be then in this new context pure math.
Okay. Is that a good idea?
I think yes, because we could associate with, once we have it as a symbol, we could associate formatting and even some simple numerical calculation.
Okay. But then That's kind of awful. I mean, but then we're effectively just introducing a boatload of new symbols.
But isn't this not what FEM, backtick, and other bigger contexts do?
Yeah, although these are a little bit more direct because they're things where, I mean, so numerical values then would just work in these.
Now, yes and no.
Bothers me.
Some of them, the record is 4 digits or something like this.
Okay, but you know what? To me, I would much prefer us to actually use entities for this than to introduce. I mean, if we have to, for some internal reason, introduce a symbol in an obscure context, fine. But I mean, to me, this is what should work, in my view.
And what about in algebra?
So, Stephen, we could do this, but we have no precedent for such a thing.
I'm aware.
Okay.
We have no
Okay.
I mean, it seems like a good idea to me. I mean, okay, so the question is, the precedent might be, you know, something like this, which we also haven't done. And maybe
there are many of this kind that we haven't done.
What are some other examples?
I think the most obvious for me would be we have a color entity and we use a color entity to specify a color in
we should make that work. We should make that work.
Well, I mean, we have a lot of mathy symbols where we use to and from entity to go back and forth.
Example?
Yeah, there's
graphs, finite groups, I believe.
Really?
So coming back to the color example that you said we should make it work. The reason we haven't made it work is that graphics is totally inert and has no evaluation rules. This means if we have it as an entity, the typeset would have to make the entity calls, which is very dangerous with respect to damage.
Okay, let me think about that for a second. So the issue is, I see. Okay, that's an interesting problem. Right, so your issue, so this particular thing here is making an entity call, right?
Okay, this one doesn't, but there are many that do. Because this got the color data, so it has some local information. But if we have
what's another color? Okay, so let's say we say color of the IBM logo. Is that going to work?
I don't know.
Why is this? Why? What on earth is this? What is that? What did that just do? I mean, it obviously returned this list of things, but what on earth is that? Those are color entities, but they weren't properly wrapped in entity wrappers.
I mean, the fact that it returned the list means it didn't find the representation, rather it did the evaluation on the alpha side.
Oh, I see what you're saying. But do you think this will work?
I doubt it. Yeah.
No. Okay. So
I was more thinking like entity value color entities, where there are thousands of or 10,000s of them.
Entity value what?
Of type color, comma entities.
Like this.
Which took a couple of seconds for me because there are quite a few. There are
10,000 of them. What on earth are all these? What?
There are HTML colors. There are a couple thousand normalized automobile colors. There are many, many colors in the world that have a name.
Okay. But okay, so let me just be clear on what you're saying here. So what you're saying is this is one case in the case of graphics where we don't get to do an evaluation.
Exactly. Like compared with geographics, where we do have non-trivial evaluation attached. So there we have time to go out, get something, do something. But with normal graphics, we don't have evaluation. So typesetting would have to do the job. And that's
horrifying.
Genius on typesetting.
That's horrifying. I mean, I think the only realistic way to do that would be on input, to evaluate on input. But that would be a change.
There would be a big change.
Is it obvious whether we care? I mean, in other words, that would be something, if we did that, we could also normalize some other things. Why don't we address that question with Brett? Let's ask him whether he thinks.
But still, it would be an evaluation rule for graphics, because this thing on its own obviously cannot evaluate.
No, I agree. Why didn't that work? That I would have expected to work as well.
But if you do two entity on that yellow box.
From entity.
Oh yeah, from entity, excuse me.
Yeah, I understand.
I mean, the RGB color, that's probably one of these gray zones where it would be straightforward to add evaluation rules.
Okay, so what does that mean? Why did from entity? I mean, insofar as from entity works with Corona yellow, is that because we think Corona yellow just is that RGB value, whereas the sonic constant?
Exactly.
Yeah. Basically, from entity is only going to work on the 8 built-in constants, 8 or 9, whatever.
Right, because it can give an exact representation, whereas for the sonic constant, it can just give a certain number of digits.
Exactly.
Which is an argument for having n work on that, because then we can give it to a certain number of digits, and it can say, oops, I ran out of digits if it has to.
We could do this.
Yeah.
Well, from entity could work on anything that can be expressed as a combination of built-ins. You could use it for
Sure,
zeta.
but it has to be an exact representation.
Yeah.
We could hook that up to work. The design right now is to just only do it if you get a single symbol back. But we could certainly.
But there's a second and a little bit more scary version. What about you have a functional identity of them, something like constant squared plus constant equal 1. Do we really want to express it through the entity? That's another reason why we have this context.
Yes, I do think it's. I don't see why not. I mean, our symbolic computation system is perfectly happy to take a picture of a smiley face as a, right? I mean, it's perfectly happy to have, if I have like a, whatever it is, if I can get this image of an aardvark to work, there's absolutely nothing that says that I can't use this. I mean, I think everything will just work. If I take the image of the aardvark, if I can get the image of the aardvark there to the power 30 minus 1, and I want to factor that. Oh, how amusing. Huh. Of course, that doesn't work anymore, because we now actually do that thing, the square of the aardvark.
It evaluates.
Oh my gosh. Interesting. Wow. Is there any way to prevent that? I mean, can I do graphics of the picture of the aardvark? No. How do I prevent the aardvark from evaluating?
Show you want rather than graphics, because show will build the appropriate things around.
Okay. This is definitely in the category of, let's see if it works now. Okay. Okay, that should definitely be in the category of possible issues. Presumably for, I don't know what for. I mean,
possible issue for what function?
Well, good question. I mean, it might even sneak into something like power. I bet this is going to have broken something. I mean, what an unintended consequence. It's a rather ugly picture of that aardvark there. We could have picked a more exciting image. But anyway,
sorry, so coming back. So if we would say that the entity Sana constant represents the thing itself, then we must go this step also for mathematical functions. And then we are where we didn't want to go, something like that the entity sign function of pi represents the thing, which I thought we didn't want to go.
Okay, so an analogous situation is with the function repository, where we have a resource object representing a function, right? And what we're going to do there is it will look very much like this. It will look very much like, so let's walk through why we don't want the mathematical function. I mean, so what we're talking about is sine function, right?
Yep.
And that's, no, that just did that. How do I get?
Yeah, because entity mathematical function sign, because this is what in most cases, or you can make two entity.
Okay. So your point is that of pi over 2
does do nothing.
doesn't.
Yeah, because there is no property
worse.
called pi over 2.
Yeah, absolutely. That's a much worse problem. Yeah, this thing was not built to stand in for a function.
Because for most entities of the real world, like cities and countries, it doesn't make much sense.
Right. Okay, so let's walk back to this thing here. This is a problem. But we don't introduce symbols in connection with mathematical functions, do we? In connection with the entity type mathematical functions, do we?
For some, yes. Like for the ones that we have, we can of course use the system one.
Right, absolutely. But what about the ones we don't have?
We also we need some symbol to write down an identity. How can we write down an identity without having a symbol? And they are right now in extension, and we were thinking moving them over into some other one like pure math.
Okay, well let's try a different possibility.
Okay.
Which may be crazy. Okay. What if this property existed? Okay. This may be crazy. And simply formatted as something which is not quite a yellow box, but something similar to the yellow box.
So the thing shouldn't evaluate. It stays as it is.
Yeah, it stays as it is, like that.
So
maybe this is crazy.
A very special one property then.
What's that?
So symbol would be a very special property, a property that doesn't evaluate.
Yeah, that's a little crazy, isn't it?
That needs hackery to avoid evaluation.
All right, bad idea.
Because there might be other domains where symbol really.
Okay, so we walked through this whole question about creating private symbols in the case of the function repository. I don't think, were you in that discussion?
No, I was not.
Okay, so this has gone around multiple times, and what we eventually concluded, and I wonder whether we can, hey, if Eric is here, could you see if you can find Brad Ashby? Let me send a message.
Because in this case, it's easier. Like if you want a certain function, you probably want it in global.
No, but we don't want to do it that way.
Okay.
Let's see. Okay, but let's continue with this discussion. So that's an issue we're going to have to resolve. But let's continue and look at some of the other things that are here. Okay, preferably in a more. Okay. So, ouch! Standard notation. That. By the way, whoever's on, got a bunch of background noise. It'd be really nice if you muted. Thanks. Okay. Using intervals for lookup. Oh, wow. That's cool. That's really quite cool. Okay, so let's see what's around. So what about, can I do a nearest? Like what's the nearest one to pi or something?
No, we didn't. We thought about doing something, but issues with precision and things sort of prevented clear design from coming through.
Okay, so if I say pi minus 0.5 to pi plus 0.5, oops. How can it have 439? Oh, I see. Okay. All right. Now, how do I get the numerical values of those? Do I just say
the value of percent, comma
numerical value?
No, it's numerical approximation. What was it?
Yeah, numerical approximation. Or you could do short numerical approximation. It's more convenient because often they have 1,000 digits if you ask for actual numerical.
Okay. Dandy. All right. Okay, so this short, let's take a look at some of these properties, like short. Okay, oh, you already did one like that. All right, what's property showcase?
This doesn't show everything. This just shows the ones where there was maybe something to point out, or where there's only, where there's not a great amount of coverage. So I had to find a specific entity to let you poke at. If you want to look at the basic EP example, that gives you maybe it just gives you a property association.
Hold on a second. Let me just think about this short numerical approximation thing. Let's see. Could somebody please track down Eric Broderick and ask him to? Anybody here could do that?
I can find him email.
No, I already did that. Okay. Just a minute. Okay. Let's go back to this. All right, so we've got this short numerical approximation. We're hearing heavy breathing. You might want to adjust your microphone. All right, let's just take a look through some of the other things here. Theorems. These are all in text?
No, we don't have a, what could they be?
Nothing. That's about it, the best they can be. But we don't, for example, the formula, the name of the theorem is not an entity yet.
Not yet, yeah.
Soon, hopefully. But this is nice. This is interesting. How many do we have?
Not too many. I think there's only about a dozen that have theorems associated with them.
We didn't spend too much energy on this part.
Is this stuff sensible? Are these the only ones, or are these? No, this is just random. So does that essentially everyone have a traditional form?
Yes.
But not everybody has a traditional form traditionally. So then we fall back to typically see with indices.
Is that a good idea? I mean, is that conventional, or where would we?
Semi-conventional, I would say.
And why is this taking forever?
Not sure.
Seems really weird. Should be instantaneous.
Yeah, it should. Not sure. I'm writing down all these inputs that give us any trouble, and I'll check it out.
I'll save this if you want, but okay. Let's try another 10. That's a bad sign.
I think the aborting made now some trouble.
Okay. Are you using the caching infrastructure, Nick's caching infrastructure?
It's probably being used behind the scene.
I was just going to say, I don't think you have to do anything active.
Yeah, you probably want to clear it out now.
But it works with one of these old style packlets?
Well, it's exposed through the entity framework, presumably.
It is, yeah.
It's not the old style backlet. It's fully entity valued with a function on top.
Okay. Okay, fine. Just a second. I really need to find Brad here, and since nobody else seems to be able to find him, I think I have to go on mute and go call him.
Yeah, I think I have seen this kind of behavior after I aborted some entity value stuff.
Well, it's also in the prototype build, so if there are any changes or improvements going in, you might be unlucky and catch them.
Well, the set stream position stuff looks a little...
From the byte files.
Yeah. Although, like, I don't know why. Well, the string split is just sort of a down the chain from there. So, but it actually returns something in the end.
Okay, hello again. Okay, let's take a look at this. How could there be a missing not available here?
Well, that's another of the Madelungs. Maybe there's just some, it's been, fine. Yeah.
These are pretty weird notations. I mean, is that really a convincing notation for the hypercube line picking constant, whatever that might be?
Yeah, I think we harvested the literature reasonably carefully.
Okay.
Hit it with traditional form and it will look the way it looks in a book. It'll turn the brackets to parens, which is it's probably either denoted that way or with a subscript. Oh, that's nice. I meant the actual right-hand side of that one.
Yeah, right. Well, fine. Okay, fair enough. Okay, what is parsing about?
You can get them through control equal.
Good. To entity from entity.
As Pogo said, this only works for the one where we do have a symbol in system backtick.
Right.
And there is a bug, a little bug here that you'll see, but I have it filed. So.
Okay. Okay. That's cute. That doesn't look very Gaussian to me, but it's amusing to claim that it's Gaussian. Okay. Kenshin's theorem. Okay. Oh, they really.
I don't think that's a Gaussian. I think that's probably a log normal, I would guess.
I thought that I had looked at. What did I look at?
Okay, but anyway, they're very close to Kenshin. The continued fractions are very close to satisfying, to giving the Kenshin the geometric mean thingy.
Yeah.
At Banford. Fairly close to Banford too. Interesting. Okay, those are all cool. All right, let's go back here. So the only remaining issue, it seems to me, well, a couple of issues. One is the short numerical approximation thing.
You want the property to be renamed or a different result?
I'm not sure. I mean, it's a little bit of a weird name, and nobody's going to readily. I mean, that's the question of whether we want to do this N thing.
The N thing can probably be done, but of course we need some approval from Rob for this.
How much of a hack is it? Does it actually have to go inside N and so on?
This probably depends. Like if it's just the entity, then probably not. Then we can associate it with entity. But if it's somewhere deep inside something, then it has to go into N.
Well, and you're not going to ask that you be able to use it as a symbolic limit in an integral or something, are you?
Like N of...
Yeah, that seems crazy. Right. Right. I mean, so the point is, if the value... Well, a symbolic limit, as in it's purely symbolic, sure. I mean, I can take one of these things. So this is where it gets a little confusing. I mean, I could take one of these things here and I could perfectly happily say, this, well, apart from this error, which I don't know what it is, but that just works fine. So the only thing now that doesn't work that you would expect to work is me saying N of this. I mean, maybe you wouldn't expect it to work, but it seems, because we can do arithmetic on these things, unlike for the mathematical functions, the entity-based mathematical functions, where we cannot.
I mean,
Although that's for a very specific, weird reason.
you don't know how many digits you can compute of one of these things. That's different from things that are built in, where presumably you can get 10 digits or you can get machine precision.
But even something much simpler, like coming back to the mathematical function comma sine, if you make this as a function of x and you differentiate, what do you expect to happen in the ideal world?
Yeah, okay. I mean, you could have some purely yeah, right. Okay. We really need to get hold of Brad. If Swede is here, could you please get Eric or get Brad directly?
Yes, Brad's here.
Bradley
Oh.
is here. Bradley's here.
Oh, well,
I don't know
thanks.
if I'm the right Brad for this.
Brad Ashby.
No. Sorry.
Guys, thanks.
I'm calling Brad now.
Okay. Okay. So what else should we talk about here? Let's look at the other properties that you have. Where was the property collection? Let's get rid of that ugly aardvark.
Keep scrolling down. Maybe close the section you're in.
Yeah.
All properties, okay. Alternate names, associated people. Okay, classes. What classes do we have?
Mainly the field of mathematics, so like number theory, constants, and so forth, and then domain information like positive, complex, rational, transcendental, things like that.
Okay. How many of them have OEIS links?
Good question. If you do mathematical,
Is it a lot or is it just a few?
no, I'd say it's been a long time since I looked. Maybe at least several hundred.
Number.
Yeah, several hundred.
Yep, that's what I'd expect.
Okay. Sine? Why do we have sine?
That was for convenience for obviously mainly complex, and there's only a handful of complex. So that's an issue where maybe we just don't.
What does sine do? I mean, for a complex.
It gives the direction in the complex plane. So
Like the capital sign function.
Well, yeah, you can find out if it's positive or negative too.
Yes.
Sure, but so what? But in the complex plane, I don't even know what's SI capital.
It normalizes to unit length.
Yeah.
We're not locating Bashby at any of his numbers.
Okay, can you see then? See if you can find Bob Sandheiner.
Yes, correct.
Uncut through.
Actually, sorry. What about Rick Hennigan?
Okay.
So if you make, say, 2 plus 5i, you see it better than just taking a thing that's already the same.
Oh, okay. It's the unit vector.
Yeah.
It's a pretty obscure name for the unit vector. I mean, it's just a feature of SIGN. I don't know.
Right.
It seems kind of
We
random.
can skip this property.
Seems really random to
We
me.
can skip this property and fold it into classes.
That seems sensible to me.
Unless there's some other property that takes abs and you have to go inside in some obscure way to reconstruct the sign. Like, how does continued fraction do that? Does it have an explicit negative first number?
Look,
Yeah.
what bothers me about all of this is, all these operations like abs and so on. I would expect the thing to somehow just work. If I pick up this thing and I say, fractional part, how do I compute the fractional part? Obviously, I can't just do this.
Right.
But so you want these things as symbols. You don't want them as entities. or you want them as symbols in addition to entities?
I don't know what I want, because it would just be good to have. I mean, there's no easy way to make that work, and certainly we can't make it work in the mathematical functions case.
Number one, and number two, it's only so pronounced here because it seems simple, but in principle there are some some built-in functions that might well operate on other types of entities, like area of a country could give the area or something like this.
Yes, well, that's true, but okay.
So if you would want my opinion, I mean, I think that, well, one reason that it looks ugly, first of all, is that that we don't have the entity, or excuse me, we don't have extension in the context path. So if we put these things, you know, if we
it's not desirable to do that, because then we're spraying. We do not want to put it in the context path, because then we're spraying tons of random symbols in there.
But we let the user potentially.
It's not a good idea. It's not a good idea, because then we're doing exactly what we didn't want to do, which is to have a lot of random symbols, in the system. We're okay having random entities like, the name of every movie and so on in the system, but we're not okay having the names of movies as symbols.
Gotcha.
Except constants are more mathy than symbols. I mean, than movies or whatever. So they're closer to being things that we want to build in some way.
All right. Listen, if we're not finding these folk who know about the function repository, we should stop this meeting. Unless we
did not find Bashby or Rick, but Bob can come in.
Is he going to be here very quickly? Because I've got to leave in a few minutes.
Yes, he is.
He may not even know about this.
Do you know what's approximately the solution of the problem?
Yes, we decided, I know what the end result is. We decided that resource objects will be, that these things are resource functions. So it looks like, resource function of, and then some string. Okay, that's the name of the resource function. And what will happen is that this of arguments will evaluate.
Oh, so it avoids the problem with the context. It doesn't solve it.
What do you mean by avoids? I mean, in other words, we will never have a... Now, unfortunately, we also discussed the possibility of symbols coming in from these resource functions. And I don't recall what the solution to that we came up with was. I think
Bob is here.
Hi, we're talking about some stuff to do with mathematical constant data, and do you remember, in the case of resource functions, what do we do if we want to have a symbol that is the analog of a resource function? Do you understand the question?
Yes. Well, you can always just set a symbol to the resource function.
No, I understand that. But if we want to introduce some random weird mathematical constant, Squiggles constant, right? Can we do that as a symbol represented by some kind of resource symbol construct?
You mean a symbol that parameterizes the function?
No, it's not a symbol. It's not a symbol. It's not an actual symbol. Are you looking at the screen here?
Yes.
It's a thing that is like one of these things. These are entities.
Right.
And the question is, so what we're doing in the case of resource function is we will have a thing, I don't know, do you know where there's a mock-up of this? Do you have a mock-up of what the visuals for the resource function are supposed to look like?
I don't have the link right in front of me. I can find one.
But resource function, at the name function, says it expects an argument. And once there's an argument, it knows what to do.
Absolutely.
Assume you would have a resource function that doesn't need an argument, that represents, say, a constant, and you want to numericalize it. So would n of resource function without the additional argument work?
No, I don't think so. But I think we discussed the possibility of a resource symbol also, but I don't think we walked through what that would actually mean. Because a resource function will evaluate when given an argument. When not given an argument, it's just not evaluating for the same reason that, plot doesn't evaluate.
Yeah. All right. I understand what you're talking about now. I don't think you may have discussed this with Rick, and he mentioned it to me. But I think that you decided that it was best for a different symbol, not for resource function.
Well, and another thing, Stephen, is that I wonder if resource function is so general that, if I want that string to just say Sarnak's constant, it would be sort of nice if or maybe there's an example where it's not clear that it's a constant from the entity blob. I wonder if maybe what you want is something that's just mathematical constant, open Sarnak, quote unquote Sarnak, close, and then that object acts like the constant in numerization and things, but the entity itself is just an entity like it's always been.
Of course, it would be straightforward to do this with resource data.
Because but only it's not straightforward to do it. It's not
because it would return the constant.
The problem is, these constants don't end. Do you see what I'm saying? We only know them to some number of digits.
Right, but it could evaluate to an entity-like thing.
But then
what good does that do? Yeah, what good does that do us?
I understand. So what do we want it to evaluate to?
We don't want it to evaluate, but we want, in this particular case, we want it to do things like n, but not to evaluate in regular evaluation.
Right. So there are special rules for how one of these things is actually integrated into the language. It has its own set of up values and whatnot.
Well, right. I mean, so the thing that we are discussing here, okay, let's enumerate the possibilities. So one possibility is, I really don't like the solution of making all of these symbols. It really doesn't seem right to me. At a symbolic level, these entities are fine. They can be used for any symbolic purpose. What are the properties that we want them to have? We want them to have, for example, do they have the constant properties? So if we differentiate them, they'll be 0.
Yeah, it seems like we would want that. Yeah.
But this will automatically happen because there's no explicit dependence on anything. Like
okay,
any
fine.
country differentiated, we give 0.
Okay, fine. Okay, so what about
numeric Q would be one.
Yeah, what do we think the answer to that should be?
I think it is no.
Yeah, I would say false.
Which it happens to be right now. Okay, so the only thing that we actually think we want is n.
Not really. Yes, this might be the most obvious, but the most tricky one is if some of them fulfill some functional equation like sine of constant equal constant.
Yeah, exactly.
How to express this identity?
Or they're even defined via simple integrals or sums. So
okay, well, I don't see the problem.
You get some simple back.
Then if this has the identity that this thing, sine of this thing equals that thing squared or something, what's wrong with that? What's wrong with stating the identity like that?
Well, if you hit it with n, it's going to give you false, probably.
No, if you hit it with n, it's going to do something reasonable, which is good. What is wrong with this picture?
No, I mean, if you hit that whole identity with n.
I'm aware. Why would it give false?
It will stay unevaluated because
it would stay unevaluated.
Oh, yeah.
Well, unless we make n work with these things.
No, there's nothing wrong with this. But thinking this now one step further to mathematical functions, stating sine squared plus cos squared equal 1 in entities.
It's crazy.
Yeah, exactly.
Okay. Boy, I thought this was going to be a really easy design review.
We need kind of a version of the Heisenberg cut. One side is entities and the other side is symbols.
Well,
that problem keeps coming up.
It does.
Where else does it come up?
Units, physical constants.
Every time we have a pretty computable language version, it becomes up. Like cities, it doesn't come up because we don't have a computable version of a city other than the entity.
I see what you're saying. Well, but for units, right now, units are not treated as entities.
Units not, but physical constants. Like fine structure constant.
Yeah, as an entity.
Yeah.
So what's your point about that?
which one do we want? We want the one that is a unit, or we want the one that is an entity?
We have this problem that sometimes we want to be able to get properties of it, but we want to be able to use it directly in computations.
Like what are conjectured
between the two rules?
What are conjectured exact values?
Yes.
But we don't have a way to ask this about the quantity version. We only have a way to ask this as a named property on the entity version.
I understand. I mean, so the trade-off is an entity can have a bunch of properties hanging off it,
yes,
but is not able to deal with functions applied to it particularly.
Exactly. Correct. Exactly.
Whereas in the other case, functions are applied just fine, but the thing doesn't have properties hanging off.
100%. This is a very good summary. Yes.
Yeah.
What a mess.
But we don't see it the first time. It's very pronounced in this case.
In which case?
In the constant case.
Yeah, I understand.
Like it's nearly a number.
It fulfills my typical meta theorem that, you know, the only language with perfect design is a language which does nothing.
New version of Hogg's theorem.
Yes, exactly so. Modeled after Hogg's theorem. Okay.
Is it a fool's test to try to enumerate every case in which it would act like a quantity, like a number?
Well, the problem that Michael is, I think in this particular example of mathematical constants, we could, in fact, you know, wire up n to do the right thing. Do you agree with that, Michael and Eric?
I agree, but it would cause a lot of unhappiness because calculating some of them, even if we have an algorithm, might take forever. Or like Chaitin's constant, there are four digits known and that's it.
How can there even be 4 digits known? I mean, isn't that, what's that?
For a concrete prefix-free language, I think there are a few digits for certain models.
I thought it was uncomputable. No, but maybe you can get. I mean, is there? Okay, fine. I mean, I don't even know why we have a constant that. Why does it still do this? That was supposed to have been fixed.
I think there are certain concrete versions that in certain model languages have been evaluated, a couple of digits.
Yeah, I think that's right.
But then why are we? What on earth is that?
Interesting.
That's very confused. Whatever's going on there is very confused.
But your session is a little bit confused.
I already quit. So
Chaitin's constant is highly machine dependent.
Yes.
Of course it is. It's the halting probability of a universal machine.
Yep.
It depends which. Well, this is clearly crazy.
Yes.
Whatever that did.
No question. This is form.
Completely crazy.
Yes.
Yeah.
Okay, and I would really think it's almost comically wrong to have a constant whose purpose in existence is to be non-computable and have it sit there with a definite number. Now, an interesting question is, do we want it to be symbolic? Could whoever's typing please mute themselves?
Sorry.
An interesting question is whether we want to include non-computable quantities and then say missing, you know, for numerical values, say missing non-computable. See what I'm saying?
Yeah.
Seems amusing, at least. I'm not sure how useful it is, but it's useful in the sense that there's metadata associated with it, including the very fact that it is non-computable.
Plus, there is a person and a year when it was introduced. There is a certain meta, as you say.
Right.
Flavor.
I think it's interesting to do that. I think it's an interesting example of our first foray into things which are, you know, symbolic but non-computable. If you understand what I mean.
Yeah.
In fact, what would be another example? I mean, another example would be, you know, we could have a function, but it would be fairly stupid, saying, you know, halting time, you know, where we basically just say, I mean, we could imagine a function, but this would be very silly, where we say halting time of Turing machine such and such, such and such, and often it would evaluate and sometimes it would not.
Isn't there not such things like convey 13 function or something like this that basically says how many times do a certain digit combination occurs in the infinite stream or something like this? And for a couple of things you can prove never, but for the majority you have no clue.
Right. Well, okay. So look, if we're enumerating named mathematical constants, we should include the non-computable ones.
Yeah.
But that's okay. Which
It
clearly
doesn't
is
solve our main problem.
What's that?
It doesn't solve our main
It
problem.
certainly doesn't solve our main problem, although it highlights another issue, which
Yes.
is if we have one that's non-computable and you hit it with n, what is it supposed to do?
Right. But the problem is already you hit an identity with n, 100 and there is no hope to ever succeed it. To just hang forever.
Right. Well,
Is there also a problem that hitting it with n, you can't get an exact value?
no, most of these constants don't have exact values. Most of these constants have some algorithm to compute them that may be incredibly inefficient. Humph. Well, okay, so what's your point, Michael? I mean, your point is just that regular, I mean, how many of them don't make it to machine precision?
Half.
Really?
Also.
No, I don't think it's that
Maybe
large
less.
a number, but
So how many don't have? So,
Oh, no, to machine precision. Sorry. I thought you meant, sorry, I was thinking on 1,000 digits.
no, definitely not. I wasn't. I mean, we're
Sorry. So, yeah.
not. Yeah. Okay, so if most of them make it to machine precision, that's at least. Do you have a list somewhere of
I can send it to you in the chat. Let me just get a notebook.
Okay. Well, send it not in chat.
Send an email.
Okay, I'm coming back to this. I really, really don't like this.
Okay,
I think this
good.
really should be the entity. But now the question is there any way, if you've got an expression that is full of, so here's a question. Should from entity, it's not going to be useful here. It's not going to be useful. I mean, one possibility, okay, so here's a bizarre idea for you. What if from entity had a second argument? Does it already have a second argument?
Yes. Yeah.
What is it?
Oh, no. To entity has
entity.
an argument.
Yeah.
Sorry, to entity.
Okay, so my suggestion, from entity of an expression, comma, and then the default property that you're using to extract, to
The meaning.
resolve that entity. See what I'm saying? So in other words, if we allowed an expression here, and so it could be something like this, for instance,
Yeah.
and then that thing said short numerical value, then you would be able to resolve this. I mean,
But from entity, the first argument would be an expression or an entity?
Well, I'm saying that we'd have to generalize that to allowing an arbitrary expression containing entities. See what I'm saying? Otherwise, it's not going to be very useful.
And it would evaluate or it would sit there?
No, I'm suggesting that from entity, no, I'm suggesting this, that from entity would take an expression like this, and normally the default would be something like identity in the second argument.
Okay.
Identity is the right thing.
Yeah.
And that would simply turn it into, pi squared or whatever it is.
Yes, understood.
But if that second argument here was short numerical approximation,
Yeah.
then instead of returning pi squared, it would return the pi entity's short numerical approximation squared.
That's I think is easily doable. But I
Does
don't
it
see how it
extend
has.
to any other domain, or does it only make sense for constants?
I would think that if you're going to go to the trouble to do this, that you would want to actually make that second argument a list of rules and say mathematical constant goes to short numerical approximation, comma.
Yeah, I mean, the other argument is, what about entity value? Because entity value, after all, here, entity value does allow a list, right, of entities.
Yeah.
Mm-hmm.
Yeah.
So why not allow entity value to take an arbitrary expression involving entities? That seems somewhat sensible as well.
Are you assuming that the property is the same for all of them? I don't think you can make that assumption. You need
No. We're making that assumption because basically what we're trying to do is have this be the equivalent of doing n. See, I mean, in whatever this is doing, whatever. But so my suggestion here would be to make something like, actually, this is not completely crazy. Yeah.
But you'd want an extension of this where you can generalize a different value for each entity in the expression.
You don't think that's crazy? I think that's pretty crazy.
I'm sorry.
I don't think it's crazy, but I don't think what it gains us. I don't see what we get.
Well, I'm sure it subverts any efficiency.
No. Look. The issue is, how do you take that expression and without 3 lines of code, replace omega constant by its numerical value?
Slash dot entity value dot e entity goes to.
Blah.
Okay.
Horrible.
Okay.
I mean, how do we take this thing and do what is basically the moral equivalent of applying n to it? And I don't understand Bob's comment, because this is specifically for yes, if you had in here a city and a type of food and things like that.
Yes, that's exactly what I'm thinking.
But it won't happen. It won't happen because those things are, they just don't combine with these in this kind of way. Now you might argue, what if it was a table? Okay, so what if you had something which was an array of things where one thing is a food and the other thing is a color or something? I mean, I think that's in the category of. I don't think.
What happens if some of them are entity classes?
Well, what happens right now if some of them are entity classes to entity value? So entity value, what's an example of an entity class? Let's say number theory constants. Is that going to work?
Probably not. First, try do transcendental constants.
I don't understand why this bug. Constants. I don't understand why this bug with the
Formatting
initial.
missing.
Yeah, I don't understand why that's still there. Okay, that didn't work at all. So, do you know the name of an entity class?
Algebraic constants.
So this is mathematical constants. Is that right?
Yeah. Oh, but singular, and yeah.
That doesn't seem to know itself as an entity class. Is it an entity class?
It is. Yeah. Let me.
Well, mathematical constant data is still blue for you too.
I mean,
The prototype build.
If you apply argument string entities to this entity class, I mean, right now it might be that just the formatting.
Oh, it's not formatting. Yeah, what's entity list?
Entity list?
No.
you have to either apply entity
Yeah.
list or call entities. Yeah, there you go.
No, indeed.
Huh. Okay, I'm not really sure. That I just looked at that today. So
Okay, all right. So what the possibilities we've got on the table are doing something like this. Okay.
Okay.
What other
I agree that this overall, Tony will not like it, but that makes some sense.
It seems the least crazy of the things we have on the table right now.
But it doesn't solve the problem. How
Why
would
not?
you how would you state an identity in this constant?
So to back up,
I'm saying this is the way you state the identity. You just state it using the thing as a symbolic object.
but why do we even need a symbol to state the identity? Why can't we just invert it and solve for the constant, maybe as a transcendental root object or whatever? Are there cases where we can't do that?
No, that's not the point. It's not for defining. It's stating identity is obeyed.
Yeah, what's wrong with this way of doing it? This seems like a fine way of doing it.
Because I feel like if we state it this way, then people will write entity mathematical function of sine squared plus cosine squared, and I really don't think we want to go there.
That won't work. I agree.
What were the, scroll down a couple lines, what were those alternate representations or whatever?
Well, look at the horror of this. Look at the horror of this thing.
Well, so there we wouldn't actually need the symbol. We only need the symbol if, say, it involves void constant multiple times in multiple.
Yeah, if the if it's some golden ratio, 5 squared plus 5,
Yeah.
Well, you could, for instance, look at representation through other constants right there. I mean, there it's unavoidable, right? You're always going to have the constant applying on the. See, so here's a good example.
Right. So you've got to have a representation, and this seems like exactly the kind of representation we want. However, Michael's issue is the slippery slope leads us very quickly to mathematical functions, right?
Yeah.
Mm-hmm.
At which point we have the horror of the fact that the function applied to something, when we try and apply the function to an argument, it's going to blow up.
It's not going to blow up, but large parts of the system would have to be prepared when they see an entity to somehow retrieve some information about it and then continue. And what is entity mathematical function sine prime? Is it cosine or is it entity cosine? Because we have
but wait a second, Michael. I mean, the issue that we're having here, we're not saying that fractional part of Boyd constant is going to work, right? We're saying that's just going to sit there.
Okay.
So similarly with mathematical functions, it's perfectly okay if the mathematical function, if the entity-based mathematical function just behaves like the function f, the purely symbolic function f.
Okay.
Right? I don't think there's a problem with that. The problem is we have a syntactic problem because the entity function, when applied to an argument, will go crazy because it is used to being fed property specifications.
Yes, correct. But what I'm saying, even without the problem of applying the argument, the function derivative makes us already problem with the entity itself.
Why?
Now, what is derivative of one of entity mathematical function cosine?
What is it for f? I mean, for f, it's just if I say, derivative of f of x, comma x, right? I get that.
Yeah.
And that thing is the derivative. Could whoever's put themselves on mute? It's just something like this. It's just a purely symbolic f there.
Yes, but derivative of one of cosine evaluates.
Derivative of one of f. Well, you're saying that if I do this thing, if I do what's your point? If
Just
I
take derivative of x without the x. That's my point. This evaluates.
Well, what does it do with an f there? It does nothing. It won't evaluate.
Exactly.
Well, that's fine. So it should just do this. It should do the thing as if it doesn't evaluate. Because if you want it to evaluate, you would do, entity value, and then you would say how to evaluate it.
I see. So you would be fine if basically derivative of one of entity mathematical function cosine would not do anything.
That's correct. I'm fine with that. I don't think there's any choice because so many of the functions we're dealing with don't have an explicit representation that allows one to go anywhere with that.
Right. But then we still have, as you said, we still have the second problem then with the argument.
That is a horrible problem. I mean, in reality, we don't have that problem, although it would require major hackery to avoid it, because in reality, the properties are all strings and things. There is no overlap in types, so to speak, between the properties and an actual function argument for a mathematical function.
Yes, but it seems it's also a slippery slope.
It's slippery, it's hacky, and I think it will crash and burn.
Yeah, I think so too.
Okay. So
we can use the entity itself as its representation of itself.
Yes, for the mathematical function, but
Yes.
what we can't do is to apply that mathematical function to anything, which is kind of horrifying.
Correct.
That's in distinction to a resource function, which, okay, so what we do in the
It's the
case of
opposite.
but what we do in the case of resource function is resource object, the corresponding resource object is a thing that has metadata associated with it, but the resource function expects to just eat function arguments. See what I'm saying?
Yep.
So is there any analog of that here? That is, we have some freedom because the thing you get from control equals, gosh. We've got the entity, and the question is there any way of generating, what is the analog of the resource function versus resource object dichotomy for resource functions? Is there an analog?
There's no higher level, so to speak, yeah. Like there's only one version of the entity. There aren't kind of two flavors.
No, I understand, but resource function, like resource data, is a kind of more active, it's an active slice that represents a particular property of the resource object. So the question is whether here we can have, how many mathematical functions do we have in mathematical function data roughly?
500.
Yeah.
Is from entity not the equivalent?
It is, but it won't. The problem, Bob, the problem is something different. The problem is, look, if we say, oops, wasn't what I wanted at all. Oh gosh, this is the problem I had before. Okay, so if I say entity, I'm sure I have it somewhere on the page here.
Mathematical function kann man sein.
Okay, let's pick a much more obscure function. Name a more obscure function.
Q binomial.
Okay, dandy. Okay, so now here the problem is we got a bunch of weird background noise, by the way. The problem here is that if I say sine function of pi over 2, it's going to say missing retrieval failure.
Because it doesn't know the property pi over 2.
Why does it say retrieval failure? Why doesn't it say property is missing?
That's a good question. I asked Tony.
Okay.
If you stringify it, it'll probably say missing property, is my guess.
If this thing, okay, so that was a pi, for example. Yeah, okay. Okay. It is interesting that those are different. Even slightly encouraging for our current purposes.
I see your point.
I mean, it's a horrifying idea. And I'm sure it will bite us in some other way. Let's just think about it for a second. Well, let's see what it does if
it would bite us for every function that eats strings.
Yeah.
Well, I know, but none of these. That's really interesting. But none of the mathematical functions eat strings.
That's cool.
At least as their natural food, so to speak.
Yes.
That's not their diet.
Yeah.
What is that called for animals? It's what they naturally eat. I don't remember.
I don't know.
I mean, you could always feed it a string. I could perfectly well. It just won't be very useful. I could feed sine a string. Just won't be very useful. All right. So look, what's on the table is the possibility of the possibility that we could treat this as a symbolic thing, that we can make entity value work with arbitrary composite expressions. And
it will get an outcry from Itai and others.
We might. Yes, we might.
I almost like your original suggestion of using from entity, even though it's a little bit of an overloading of the symbol. Then, I mean, from entity is not nearly as useful as integral to the language as, you know, entity value.
By the way, we have a couple of comments from people who are watching this live stream that are kind of interesting. One person asks, are these constants going to be integrated into everything else, or are they just a basic entity store? Suppose I'm doing computations for an arbitrary problem and the result happens to contain a mathematical constant. Will it be represented using this mathematical constant data? So the answer is, right now, I don't think we have any, we do not imagine that any built-in functions will return things which are only in mathematical constant data. In fact, I don't think that's ever going to happen, because I think as soon as it is something that we expect to return from our internal algorithms, it will have to be some, we will want it to be something where we have properly integrated the mathematical constant into the system.
Correct.
And so I don't think that, but I mean, these are really pretty much, well, they're primarily things that are just sort of constants where you're going from the name to the properties. You're not going from the some generative process to the constant.
Right.
Someone else is asking, what are examples of properties that are not strings? Well, there's certainly things like dated and so on, but that's really not a great, I mean, those are special cases.
They're not properties, they're qualifiers.
Fair enough. I mean, but dated appears in this property position.
Yes. Yeah.
I have to go, guys.
But they're a shortcut for something else.
Right. See you, Bob.
Doesn't chemical data and element data, oh, those are entities, those aren't properties. Yeah.
What are entities?
Non-string, symbolic, or
entities. Yeah. Well, those are being updated anyway, but all right, look, I think the best we've come up with here is the entity value approach. Let's figure out how horrified people are by that.
But the entity value approach we don't need in some sense. All what we need is to, wherever we currently have extension backtick something, we stick in the entity itself.
Sure, that will be fine. Well, actually, I wouldn't even bother in these cases for the alternate definitions. I wouldn't bother here.
Yeah, I agree. But say for what do we do for mathematical functions where we do have arguments? There, the entity value does not really solve it.
Why?
How would it solve it? Like assume you have some identity of some function g of x plus g of y. How does the entity solve this?
Okay, so what I'm proposing is that this, I mean, and by the way, what you're doing here with inactive versions, you know, you can perfectly well say, I mean, in this particular case, you could say something like that, right?
Yes.
But the problem is when you activate it, it's just going to go bonkers.
All hell breaks loose.
Right. Except if we put in this hack to prevent it saying missing retrieval failure and leave it symbolic in this case. I'm really afraid of that hack.
I'm not sure if it can even work, honestly. Because assume you have earlier defined x equal and then comes the string of a property.
Oh, then you're going to get a stupid answer. Yes. I mean, this is a deeply slippery slope.
Yeah.
There's no question that, I mean, but that's the specialness of strings as properties is sort of an established, you know, that's a horror that's already happened.
Yes.
I mean, this is, yeah. Well, let's investigate whether this could work or whether there's something that absolutely kills it for some other reason. I suppose Oh, I don't know.
I don't think this will work.
All right. What can we do with inactivation? But it's still pretty horrifying because even if it's inactivated, it's not going to help us because the entity value has got to resolve it to something. No, actually, if it's inactivated and the entity value resolves it to something before it becomes activated again, we're in good shape.
But I was thinking such an object would be the return of something. Like you ask, do you have the Q binomial coefficient, and you asked for functional identities and assume there's Q binomial squared plus 3 Q binomials equals 3.
Fine. So if you had inactivated Q binomial, that
would work. I do agree this would work.
Right. Okay, but and then walking through that, if you did entity value, so let's say there was a functional approximation, for example, to the thing. You could say entity value of the thing, common a functional approximation. The functional approximation would substitute itself into the inactivated area places. Then you would say activate and all will be happy.
I don't see a problem right now
with that. But I mean, the problem is the problem that I do see is the obvious syntactic way to enter. So if we put all the identities for these, like the Q binomials, with inactive, it will work.
I think that's a correct statement.
Except, is it going to prime someone to see that and try and activate it right away without doing this? And I mean, because now
then they'll go bonkers.
Right. So somehow we have to describe this whole workflow in the docs, and I don't know.
Yeah, I mean, it's a bit horrifying.
I almost feel like, constants are a special enough case that, if you wanted to avoid restructuring a lot of things, maybe just give these things their own symbol mathematical constant of open close. I mean, it's basically just like an entity blob, but at least then people know, okay, this is a special thing.
I think that's a bad idea.
Yeah, because it's got all the other features of being an entity. Plus,
also,
there's a whole set of expectations.
This reminds on matrix function, which then really has properly to work. Like then you really expect it to calculate many digits and all kinds of things.
Yes.
Which we really cannot fulfill because nobody can.
Right. Okay, so let's walk through this one more time. Okay. So the thing currently on the table is to generalize entity value, which I think is reasonably sensible. That works so far as we know with mathematical constants. There are no obvious problems with that, correct?
I don't see one.
I don't see, no.
Okay, all right. Now let's talk about that same idea applied to mathematical functions. Now, what we're doing right now, if I look at Q binomial and I look at its functional relations and things, am I going to see sort of put up symbols in there?
Yes.
Yeah.
Okay.
Q binomial is a built-in one, but for other ones, yes.
Okay. Okay. Well, so the alternative thing
actually, with one refinement, like if we would have some special typesetting for the inactive of entity, then I think I would actually really like it.
Okay.
Because like typically a math formula, you want to see something reasonably compact, kind of you don't want to see a big formula with yellow boxes. I feel like it feels too unusual, too unconventional.
Okay. So you're suggesting that if we did this, that we could, it reminds one of pork somehow. If one could get this extra little piece in, then we'd go for it. But let's think that through. Okay. So what you're saying is that if we could have inactive of this type of entity, at least, being something that would show a shortened form.
Yeah.
Well, then people would at least not think they knew how to type it in.
Right.
That has another advantage going for it. All right. But so what roughly would it be? It would be some kind of traditional form of the thing with some box around it somehow.
Yeah, exactly.
I think actually this might be a good place to generalize, because what you could do we have something like labeled? I don't use stuff like that
Yes.
often.
I
So-
mean, for graphics.
But that's for graphics, yeah. So what I'm thinking of is, like, can I take an arbitrary expression? So I'll just call it label for now. If I do label, no, I can't do that. Label X.
Well, this does that. I mean, that's how that works.
Right, but what I want to do is I want to have an expression, just any old expression, in the first argument, and the second argument is, say, a string or perhaps a row.
Yeah.
And then basically it's kind of the opposite of an annotation. It acts like the expression, except that it displays as a purple box, let's say.
You want something
yellow
like
box.
iconize.
Yeah, iconize, something like that.
Which we just built,
Okay,
conveniently enough.
yeah. So what if
I don't think we need that mechanism. I mean, I think that's a different mechanism.
We
But
just need like if there would be a special property for the entities that would say how to represent myself as when inactivated, then we would have everything together.
Okay, well, let's walk through that. Why do we need that as opposed to a thing which actually just is the formatting of inactive of an entity?
That's the same. Somewhere this formatting must live and come from.
Oh, I understand what you're saying. Well, that's fine.
Because it might not be a built-in entity, it might be a user entity and an entity store. That's why it needs somehow be a property.
That's interesting. That's interesting. Yeah, that's interesting. Okay.
So we have a universal, like inactivated entity format.
Well, I mean, look, it will be what it basically is the display names, right? Are things like common name, right? That's
exactly.
What
It's a flavor of this, yes.
Right. So what it would be is, inactive display or something like that.
Right.
Inactive display form.
But it would be more complicated because, like, if you think of mathematical functions, there are subscript, superscript.
Right. But I mean, so it can say an active display form, and it's an arbitrary box structure.
Exactly.
Okay. I think we got a solution here.
I like this.
Yeah, actually. And I would suggest that I still kind of like the boxiness of an entity-like thing. Like, you know what I mean? Like, I don't know if just having just a box, how do I tell that this is specifically something representing an entity? Maybe we should color it or something,
Sure.
Like units, physical quantities can have a little background or something like that.
Yeah.
Right. Very similar to one of those. But I think what's interesting here is that we've essentially, the solution here is analogous to the solution between resource object and resource function.
Yeah.
Namely, the entity here is the resource object, which has all its properties and so on associated with it. And what we've done is we've said that inactive is the kind of semi-hacky thing that corresponds to the resource function.
Yeah. I like it, like if we go into the direction, if we think on, say, mathematical structures, abstract mathematical structures that are so abstract that we cannot calculate anything with them. We still want them as entities because they have properties, and we want to write down classical, traditional math identities in them.
You're
and
right.
also solve this problem.
Yes, this is nice. Because anyway, those things are full of inactivation because we don't actually want...
Exactly. We don't want it active to be anyway.
Yeah.
Because it shouldn't reorder with respect to plus and even such stuff.
Although we do expect canonical, we do expect double equals to work because these things have been, if they are canonicalized, then we expect identity testing to work, equality testing to work, which it will.
It should.
All right, very good. That was
I
great.
like this approach.
Okay. All right, anything else we need to figure out? I think we're done here. We got a good solution to this.
Yeah. That's a good,
okay. One last little piece though, with the entity value thing, where you have the third argument.
Second argument. What are we talking about? There's no third argument.
You mean that if that first argument is an arbitrary expression containing entities?
Yes, that one.
We need to explore that. That's not.
I will discuss with Tony.
Separate meeting. Okay, gotcha.
Yeah, that's a different story. It sounds. I think probably if we wanted, we want probably the second argument an association, like with this entity type do this, with this entity type do this.
Yes, that was the point that's exactly what I was going to say, Michael. So okay.
Sounds good. All right.
Okay.
Thank you all very much.
Thank you.
Okay.
Bye.
See you. Bye-bye.